Hello everyone, this is the ME416 final project. My name's Kevin and I worked with Abdullah during this project. We were assigned the rectangular angular fin for this project, and our goal was to analyze different materials and lengths, including copper, aluminum, and steel. Also, we wanted to find the heat transfer rate using a model in ANSYS. These were some of the parameters for our project. One thing to notice is the conductivity for each of the materials, and with these parameters we wanted to analyze the length of the fin, find the thermal efficiency, and also the heat transfer rate. This is a 3D model of our prototype. We were assigned the rectangular annular fin. These were some of the values that we input to find the thermal efficiency. We had to come up with R1, R2, and then from that we could find the area and the length. This would help us compute the thermal efficiency later on. This is the mesh for our annular fin that we found using ANSYS APDL. These are the thermal gradients for each material. The first is stainless steel, which had a minimum temperature of 130. The maximum was 150 for all the materials. This is the gradient for copper, which had a minimum temperature of 148 degrees. The last material we analyzed was aluminum, which had a minimum temperature of 147 degrees.
These are the data and equations to compute the heat transfer rate and maximum length. These are the results for heat transfer rate for stainless steel 28, for copper 111, for aluminum 76, and the maximum length for stainless steel 0.16, for copper 0.67, for aluminum 0.45. In order to find thermal efficiency, we had to compute a couple of numbers and equations from the graph, and we had to get the equation 1 and 2 in order to get the thermal efficiency. The thermal efficiency for stainless steel 15%, for copper 73%, for aluminum 50%. In conclusion, as the thermal conductivity of the utilized material increases, the distinction of the heat exchange rate between the computational outcomes and the expository arrangement increases. At the point when the length of the balance in ANSYS is its hypothetical most extreme size, the tip temperature is bigger than the surrounding temperature. When the fin is in maximum size, the longest fin is copper fin because of its high thermal conductivity. Thank you for listening.